Hey everybody, and welcome to another JASP tutorial. What I want to do in this video is walk you through how to do a one-way ANOVA. So just a quick little bit about the data set that I have here. I have a data set where I have two different factors. I have group and I have condition. So group being sober and intoxicated, condition being no sleep, sleep deprived, or normal sleep. And so each group had people in these three conditions, so subgroups. And then we also had two dependent variables: accuracy on a memory test and reaction time measured in milliseconds on a memory test. So I am interested in how can I analyze this? How can I make sense of it? I can't use t-tests for this. So what you want to do is you want to run up to Anova. You want to click on Anova, not surprisingly. So what you see here is a source table, so this is going to populate as we throw variables in here. And for the dependent variable, you want to use the measure or the value that you normally think of as your results. So I have two of those here. I have accuracy and I have reaction time. So I can only do one at a time. If I were to do both at a time, that would be called a MANOVA, which is multilinear and is beyond what I want to trust right now. So instead, I just want to look at these one at a time. So I'm going to go with accuracy first. So I'm going to throw accuracy in the dependent variable, and now I can pick between these possibilities. I can throw group in here, and then it'll analyze accuracy by group, or I can throw condition in there, and it'll analyze accuracy as a factor of or as a product of condition. Or I can do both of them, and that is what we'll do soon. But first, I want to just look at it in terms of group. So I just throw in group right here, and we can see what appears to be a significant effect. The way that you interpret this is basically group is your between variable sum of squares. Residuals is going to be your within subject sum of squares. And so as we move across, you can think of this as like your between group sum of squares, your between group degrees of freedom, your between group mean square, and then finally your F value, which of course is going to be, your F value is dividing your between groups mean square by your within groups mean square. So that's where that value comes from. You can see this is less than 0.05, so we feel successful here. But yeah, so this is not maybe too surprising because we could have done this with a t-test. And just to show you, I can go over to t-test, I can go over to independent samples, and then I'm going to group the accuracy by group, the factor that I have here, and you're going to see the exact same thing. Of course, it is very significant. Okay, but that's not what we want to know. What we ultimately want to know, what we're dying to know, is whether or not group and condition together give us anything interesting. And so what we're looking at here is the between subjects value, and this makes it a two-way ANOVA. So we have group as a between subjects factor. You can see that it is significant. Condition as a factor, you can see that that is significant. And then group by condition, so this interaction variable, and we see that that is not significant. If it was significant, then we would need to do some post hoc tests to better understand what's going on with that data here. Now the way that you can do that is going to be at this nice little post hoc test button. You click on this and it gives you lots of different ways of splicing the data. Because I see that group is a significant variable and that condition is a significant variable, I don't know which of those variables matter. Which are they all affecting the data, or is it that one of them is different than the other two? We need to find that out. The way that we can find that out is to go to post hoc, drag over condition, and now you have this nice new table that tells you where those differences come from. And so what I'm looking at here is basically differences across every kind of group. So if I'm comparing the no sleep with the normal sleep, you can see that it is significantly different. If I'm comparing no sleep versus the deprived condition, you can see that it is significantly different. The only one that's kind of close, I guess, to not being significant is the normal and the sleep deprived conditions. But you may be saying, but wait a second, what about the groups? What about sober versus intoxicated? The way that you could look at that is moving that aside, and then putting group by condition because you want to look at both variables, and then you can see all the different combinations here. And so we shouldn't really be looking at this just because we did not find this interaction variable to be significant. But just in case you want to explore the data a little bit, you can see that there are some conditions that are not significant and some that are. So, for example, I'm looking at intoxicated sleep. So the group is intoxicated, the condition is no sleep, and I can see that it looks like when compared to intoxicated sleep deprived, there's not a significant difference. So that is, so that is interesting, but because this was not a significant factor in your Anova, you shouldn't really report this stuff without lots of qualifications. Here again, we can see that sober and no sleep is not significantly different from this intoxicated sleep deprived. And so, if I wanted to work a story up about this, which I shouldn't, because I just said that the rules are you're not supposed to really dig into this too much if you don't have good reason to, and I don't have good reason to. But I can see that the intoxicated sleep deprived condition is not different from the sober no sleep condition, which must mean like, ooh, maybe people do just as well when they're sleep deprived and intoxicated as somebody who is sober who has not slept, or something along those lines. But you can find lots of cool information here. One thing that I really love about JASP is its ability to toggle in and out of the different post hoc corrections. So usually Tukey's and Bonferroni's are very popular post hocs, and you can see how easy it is to compare those values whenever you are analyzing your post hocs here. If you'd like, you can also plot stuff in R. This one is a little bit harder to interpret, so you might have to play around with it. But usually on the horizontal axis, you want what do you want your x-axis to read as? So think about the factors that you want on your x-axis. You can put that in the horizontal axis. I want my conditions here to be that, and so you can see right here plotting that data out. Let's see. There we go. That no sleep, normal sleep, and sleep deprived. And if I wanted to, then I can also throw group in as separate lines, and you can see there, yep, that does not look like an interaction because these lines mostly look parallel. So we have the different groups right here, and so you can see how to read that as well. So, the plots are not bad, they look much better than SPSS. But if you did not want this data on the same scale like this, you can always move it over to separate plots, and that'll give you two separate ones, and there you go. And you can see how the accuracy is very different there. If you are interested in, what else? Effect sizes, you got your stuff here. Bootstrap there. But if anybody knows what these three things are, let me know because I didn't learn that in grad school, so I can't tell you how to use those. If you have specific ideas about the contrast here, and basically what that means is like if you had very specific predictions, a priori hypothesis predictions, then you could start moving around some of these weights to look at these separate contrasts. Not something you generally have to do unless your hypothesis calls for it. And we got now some non-parametrics, some simple main effects, which are all helpful, but a little bit specialized. All right, so that's pretty much it. If you have any questions, let me know. Otherwise, thanks for tuning in. Bye.